The gravitational tug of the sun and the moon could be driving the tectonic plate motions of our imbalanced Earth. This is according to Talia Ogliore of Washington University, St. Louis on phys.org. A study led by geophysicist Anne M. Hofmeister in Arts and Science at Washington University, St. Louis, proposes that imbalanced forces and torques in the Earth-Moon-Sun system drive circulation of the whole mantle. Now we know that the moon affects the tides, the water tides, but it also affects earth tides. Yes, the moon also affects the earth and could cause earthquakes. Now that's from past articles that we've read. Now, new analysis provides an alternative to the hypothesis that the movement of tectonic plates is related to convection currents in the Earth's mantle. Convection involves buoyant rise of heated fluids, which Hofmeister and her colleagues argue does not apply to solid rocks. They argue that force, not heat, moves large objects. This new research is published in a special paper of the Geological Society of America as part of the forthcoming collection assembled in honor of geologist Warren B. Hamilton. Earth's internal workings are popularly modeled as dissipating heat generated by internal radioactivity and from leftover energy created during collisions when our planet formed, but even mantle convection proponents recognize that that amount of internal heat energy is insufficient to drive large-scale tectonics. And there are other problems with using convection to explain observed plate motions. Instead, Earth's plates might be shifting because the sun exerts such a strong gravitational pull on the moon that it has caused the moon's orbit around Earth to become elongated. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. So the sun, they said, instead the Earth plates might be shifting because the sun exerts such a strong gravitational pull on the moon that it caused the moon's orbit around the Earth to become elongated. Over time, the position of the barycenter, that's the center of mass between the orbiting bodies of the Earth and the moon, has moved closer to the Earth's surface and now oscillates 600 kilometers per month relative to the geocenter, Hofmeister said. So this sets up internal stresses as the Earth continues to spin. Now, does that mean that we're going to have more earthquakes, more volcanic activity, or even greater earthquakes and greater volcanic activity, God forbid? Now, Hofmeister says, because the oscillation barycenter lies 4,600 kilometers from the geocenter, Earth's tangential orbital acceleration and solar pull are imbalanced except at the barycenter. The planet's warm, thick, and strong internal layers can withstand these stresses, but its thin, cold, brittle lithosphere responds by fracturing. So here we go, we were talking about earthquakes and volcanic eruptions, because where you have the tectonic plates, the fault lines there, that's where you usually have the volcanoes. Now, daily spin flattens the Earth from a perfect spherical shape, she says, which contributes to this brittle failure of the lithosphere. These two independent stresses create the mosaic of plates observed in the outer shell, the author suggests. The variety of plate motions comes from the changes in sizes and direction of the imbalanced gravitational forces with time. But how to test this alternative? Hofmeister suggests one test would be a detailed examination of the tectonics of Pluto, which is too small and cold to convect, but has a giant moon and a surprising young surface. The study includes a comparison of rocky planets that shows that the presence of the longevity of volcanism and tectonism depend on the particular combination of moon size, moon orbital orientation, proximity to the sun, and rates of body spin and cooling. Earth is the only rocky planet with all these factors needed for plate tectonics, Hofmeister said. She said, our unique large moon and particular distance from our sun are essential.